Hello everyone, thank you for your attendance today. I'm Jean-Pierre Dodel, or JP, Product Manager for Amazon Kendra, an exciting new service we launched in preview at reInvent last year and have now released for general availability. Today we have some exciting information to share with you. We're going to talk about Amazon Kendra and how you can transform the way you search and interact with enterprise information using AI. So for our talk today, here's a quick outline. We're going to start by talking about Amazon's track record around innovation in machine learning. Then we're going to talk about the AWS ML stack and see how it's organized. We're going to cover enterprise search and why it's still a challenge today. And then we're going to answer the question about why AWS for enterprise search. We're going to look at the industry and rethinking enterprise search there. Then we're going to cover how Amazon Kendra works at a conceptual level, cover some use cases. Then we're going to jump into some demos and general availability features we recently released. And then we're going to wrap it up with some customer references and how these customers use Kendra. So just to give a quick context on how far back Amazon has been innovating with machine learning. For more than 20 years, machine learning has been at the core of how Amazon improves our services and drives customer value. We started by applying deep learning to recommendations on Amazon.com 20 years ago with people who bought this also bought that. Over time, we not only improved the models, but we developed entirely new approaches and techniques to expand machine learning to other areas such as Amazon Prime, Prime Air, and our automation robotics at fulfillment centers. We also developed state-of-the-art speech recognition, text-to-speech, and natural language understanding with Alexa. So to better understand AWS's offering of ML services, we see the machine learning stack having three key layers. The bottom layer contains frameworks and infrastructure for those comfortable building and maintaining their own machine learning platform and underlying infrastructure. These are services like Gluon, Elastic Inference, TensorFlow, etc. In the middle layer are the machine learning services that make it easy for machine learning developers and data scientists to build, train, and deploy machine learning models. This is where you'll find Amazon SageMaker, SageMaker Studio IDE, Marketplace for ML, and other services. The top layer has AI services that allow developers to use pre-trained and auto-trained models to add intelligence to any application without machine learning expertise. In this higher level of abstraction is where you'll find Kendra, our new ML-powered enterprise search service. So let's talk a little bit about enterprise search and why it's still a challenge today. Well, it turns out that after all these years with enterprises trying different search solutions, employees are still spending 20% of their time looking for information, and 44% of that time they don't find what they're looking for. And when we talk to our customers about the challenges, the first thing they bring up is low accuracy. With 80% of the enterprise data being unstructured and growing exponentially every year, the problem is only getting bigger. And keyword engines are still very prominent in the enterprise, and they're really not fit for finding precise answers in unstructured data. The second challenge is complexity implementing enterprise search. Companies still have scattered data silos over the enterprise. It requires extensive manual maintenance, for example, tuning relevance over time as information trends change in the enterprise, or keeping those ETL jobs updated. So overall, it's really difficult to set up, aggregating all those data sources and bringing everything into a single index. So the impact on the enterprise is overall lower employee productivity because it just cannot find the information and they keep trying. There's also an increased risk and liability when the right information or standard operating procedures are not surfacing when people are searching for them. And when employees cannot find work done by previous teams in previous projects, it'll just create duplication of work. And overall, it just creates a negative customer experience. An external study found that if you were to monetize the time lost per employee, it comes up to about $5,700 per employee per year. For a 20,000 employee company, that's a lot of money. And this is just on time loss alone. So let's talk about rethinking enterprise search. And the first question you might have is, why AWS for enterprise search? Well, as we mentioned earlier, we've spent 20 years developing and fine-tuning deep learning models for search and recommendation on Amazon.com. We're also recognized as a leader in AI and ML solutions and offer a broad range of widely adopted machine learning services, as we saw earlier in our ML stack. Customer obsession. Those of you who are familiar with us know about our customer obsession. Those of you who are new to us, this is our number one tenet that drives everything we do at Amazon. We build what our customers tell us they need. So when we talk to them about enterprise search, we see the diverse mix of technologies and vendors storing knowledge in the enterprise. We don't favor any particular system. We build integrations into Kendra for the repositories and technologies our customers need the most. And this is really critical for enterprises in order for them to tap into all of their knowledge capital. So as we rethink enterprise search, we wanted to focus on the two challenges that we discussed earlier. On the left-hand side is accuracy, so making it easy to find what you're looking for. And in order to do that, we wanted to focus on four main components. The first component was supporting natural language queries to make it easier for users to ask questions more intuitively and more precisely. But in order to do that, we knew we had to build from the ground up a new engine that was built on state-of-the-art natural language understanding in order to understand the nuances of language and find precise answers buried in millions of documents. The third component was making sure Kendra was familiar with a wide range of domains in order for it to find accurate answers, whatever the business context is. And the fourth component was providing continuous improvement so that Kendra would improve over time by observing search behavior and learning from user feedback. On the right-hand side, we're tackling the complexity of implementation, and two key points come up here. The first one we wanted to focus on was providing a better way to aggregate content from a wide range of repositories. So we built native connectors to popular data sources to streamline the aggregation of content and avoid creating complex ETL jobs to bring the data in. The second option was to make sure users could test their searches in the console right away after indexing and have easy deployable options to replicate search functionality into their applications. So when we rethought enterprise search, we wanted to focus on a key thing, which is finding better answers. So we focused on three models. The first one is reading comprehension. This one really focuses on finding that needle in the haystack, that really precise answer, the word, the phrase, or a paragraph buried in millions of documents that answers very specific questions. Kendra provides an easy way to load up all the FAQ documents that have curated questions and answers, and this model really focuses on finding the best matching question in order to return the curated answer. And the third model focuses on document ranking using our deep learning semantic models. This is the more traditional approach of recommending documents in the search results. The combination of the three models delivers a powerful and rich search experience, and we'll show you some examples of that shortly. So we talked about enabling end users to ask more intuitive questions. So what kind of questions can they ask? Well, natural language queries, like if I have a problem with my computer, where is the IT support desk? And instead of getting a long list of documents, I just get an answer like first floor. Or asking a question like how long is maternity leave? And getting a specific duration answer, 14 weeks. If I have a more descriptive question of how do I do something? How do I configure my VPN? Then I get a step-by-step, a longer paragraph that tells me exactly how to do that particular task. Of course, in addition to natural language queries, we support regular keyword queries. If you have a more general question, so for example, health benefits or parking allowance, and we'll still rank those results using our deep learning semantic models. As mentioned earlier, we optimized Kendra on 14 major domains, and this was to ensure that Kendra would be familiar with the content across a wide range of industries and would be able to extract very accurate answers in those documents. Continuous improvement focuses on making sure Kendra improves its accuracy over time and stays up to date. And the first technique to accomplish this is incremental learning. This is a feature that will become available a little later this year. The idea there is that Kendra will be able to capture click-through data, interactions from the users, what they're searching for, what they're clicking on, what they're opening, in order to feed that back right into the models in order for it to learn to re-rank the results and keep improving over time. As Kendra captures these signals, it retrains the models periodically and automatically, transparently from the users. The second component in continuous improvement is relevance tuning. This is a feature in Kendra that allows customers to fine-tune Kendra's relevance by providing simple boosting mechanisms to indicate whether a particular data source is more authoritative than another one, or if document recency or document freshness is important to boost results. You can also boost based on particular authors or departments, or if you have a forum, or if you're capturing upvotes or document popularity, you can use these signals to boost specific search results. So overall, this is about fine-tuning Kendra's accuracy in combination with incremental learning. As mentioned earlier, to address part of the complexity in implementing enterprise search, we are building native connectors directly available in the Kendra console to streamline the content aggregation and avoid building complex ETL jobs. Today, we have 6 connectors available: Amazon S3, RDS databases, SharePoint Online, OneDrive, Salesforce, and ServiceNow, with many more planned for later this year. So once you've aggregated your data in Kendra, you're going to want to test your search and see what kind of results you get back, and perhaps even tune the results if you need to. So the console provides a search section where you can do these exact steps. And once you're happy with the search results, we provide code samples for you to deploy search functionality into your own application. On the security side, all of your data is encrypted. When data is being transferred from the repositories to Kendra, it is encrypted in transit with HTTPS and TLS, and the extracted content that needs to be stored in the index for search and results purposes is encrypted with AWS KMS keys or customer-provided KMS keys. So how does Kendra work? Let's look at a conceptual diagram here. So at the core, we have Kendra's core engine, and we see the interaction at the top from the users, possibly making their searches through a web page, a search box, and getting answers back. They could also be interacting with Kendra via a chatbot application or some other application that implements Kendra's APIs. These 3 objects here represent the models that are able to extract the different kinds of answers in the documents. FAQ matching, like we discussed earlier, reading comprehension here, finding that needle in the haystack, returning very specific answers extracted from documents, and document ranking here, providing recommended and related documents. And we'll show shortly how the combination of those 3 delivers a really powerful experience. At the bottom, we see the aggregation of a wide range of data sources, the connectors acting here as a conduit to bring the data into Kendra. And these 2 pieces focus on the continuous improvement. These are the sliders that allow our customers to boost search results based on specific business context. And this is incremental learning that will work transparently to improve search results over time. Getting started is super simple. There are 3 main steps. The first one is creating an index. This is basically your container where you'll define data sources. So as a step 2, once you've created your index, you add your data sources. This could be Amazon S3, SharePoint, Salesforce, and all the other data sources we'll be adding later this year. Once you've configured your data sources, Kendra can synchronize with those remote repositories to make sure the index is kept in sync with those repositories. So any additions, deletions, or modifications to documents will be reflected in the index automatically. Once you've aggregated your data, step 3 is to test search right there in the console. And once you're happy with the results, you can deploy Kendra Search into your own applications by using the code samples provided in the console. What does the experience look like? So step 1, as we talked about, is to create an index. So very simply, you just provide an index name, some description here, you provide an IAM role for security purposes, and you just click on Create. Once you've created your index, step 2 is to configure data sources. So today, we provide 6 connectors to these different data source types, and you can add any combination of them to bring data and make it searchable. Optionally, you can add FAQ documents that you've authored, And these are loaded into Kendra as CSVs that contain questions and answers. And because we have that specialized FAQ matching model, you can gain some really high accuracy by targeting the questions to return the curated answers. So once you've ingested your data, you're ready to search. The Kendra console provides a search section where you can just start typing in a query. So let's take an example here where I'm actually looking for the IT support desk because I have a problem with my computer. I can start typing in the query here, and this query auto-completion feature will be available later this year. But let's just say I type in, where is the IT support desk? And to do a comparison of what it looked like before we applied the Kendra experience, on the left-hand side, we see a traditional view of what it looks like to use a keyword engine. So if I type in the keywords IT support desk, what I get back is a simple match of keywords, IT and support, but the actual documents coming back are really not relevant. There's other terms being matched here. The keyword engine doesn't really understand the context. So I keep trying a different combination until I get something a little closer. In comparison, on the right-hand side, this is the experience with Kendra. If I type in the question, where is the IT support desk? Immediately at the top, I get Kendra's suggested answer, first floor. And to dive deeper into this particular experience, that card at the top is called Kendra's suggested answer, and it is the result coming back from reading comprehension, which is basically looking at the most specific answer it can find in the documentation and brings it up here so that you don't have to go drilling down through documents looking for that specific answer. In this case, it found the answer in this document here. It provides some context on where that particular answer was found, and it just makes it really prominent here so that you can quickly get to the answer and go back to what you were doing. So at this point, my search is done. But Kendra also provides some additional features in the search results page. If you loaded some FAQ files, Kendra will try to match those as well, and if there are some high confidence matches, we will return those results here from FAQs. And the third section at the bottom returns a traditional list of documents that are recommended for this particular search. Let's take another example where I might be a new Amazon employee and I'm wondering about the employee discount program. This is not a natural language question. It's just a keyword question, Amazon.com, employee discount. So when I type this in here, Kendra's suggested answer here shows me some elements that are in bold, guiding my attention straight to the answers. So it tells me right here, it's 10%, there's a 10% discount up to the value of $100 annually. So I'm done with my search. I got my answer. No need to drill into documents. Similarly below, any questions matched in the FAQs will be returned as well here. We also support here on the left faceted searching or filter searching. So any metadata that would have been brought in through the ingestion process can be automatically surfaced here to provide navigation and filtering capabilities for the application. Relevance tuning is about providing Kendra with specific business context in order to influence the ranking algorithm. For example, let's say I had marketing documentation stored in SharePoint and I wanted to boost results coming from that because that particular data source is more authoritative. In the Kendra console, I can easily take this slider and bring it up here to assign a higher weight to this particular data source compared to others. So documents coming back in search results from this data source would get boosted. A second example of boosting search results could be based on view counts or like counts. If you're capturing numeric values from forums, for example, or other applications that are capturing this type of popularity signal, you can boost search results based on this numeric value. A third example of boosting could be based on document freshness. In these cases, documents tend to be time sensitive. For example, more recent quarterly reports may be more important by default than older ones. So this is a great way to boost the recent ones compared to the older ones. Finally, when you've tested your search and tuned it, you can come to the deploy mode. When you come here, this toggles you into a mode where you can hover over these different search components and allows you to actually download code samples to replicate that functionality into your application. Alternatively, you can actually download the entire interface here as a starting point for your own application. Let's talk a little bit about use cases now. Kendra is a great solution for internal search, supporting business functions such as operations, customer support, R&D, finance, HR, and other functions where employees need to find precise information in the enterprise. External search cases are very critical to us as well. These are our customers building applications for their own customers. These are search applications that power search for products and services on their website or customer service self-service tools to improve their own customers' experience in finding the answers they're looking for. A third use case is CRM, content management, and e-discovery. ISVs want to build more intelligent and data-driven applications using Kendra. Here, they're embedding Kendra to improve the search experience in their own products and services. The fourth use case is FAQ chatbots. This one's getting a lot of traction now, as Kendra now provides the ability for chatbots to extend the range of questions they're able to answer by leveraging Kendra's natural language understanding capabilities. As we know, chatbots are highly optimized to handle specific intents. So when they encounter an intent they don't recognize or are not super confident about, they can now call Kendra to extract specific answers from FAQs and unstructured data. If you want to read more about this, we have a Kendra Lex integration article published on our AWS blog. There's also a Q&A chatbot. Provides easy multi-channel chatbot creation on Lex or Alexa with a Kendra integration. All right, let's jump into the demos. This is the fun part. So for this demo, I wanted to pick a data source that would allow us to compare the traditional search experience on a website with the Kendra experience. So our data set is going to be from our own retail website, amazon.com/help, which provides a search interface for retail customers to search for information related to their Amazon Prime services, Kindle books, Echo devices, and other Amazon products and services. So before we jump into searching, I want to show you what the console looks like and how easy it is to get your content into Kendra. We're going to look at setting up two popular data sources, S3 and Salesforce. So I've already created my Kendra index, as we saw earlier in that simple configuration screen, and I've called this index Help Pages Index. So let's add our S3 data source. We're going to click on Add Data Source. And here I have my list of connectors that are available to me, and I'm going to pick S3. I'm going to give this a name, my S3 pages. I'm going to skip the description and click Next. Here I can give the S3 connector the bucket where I want to pull the content from. So I'm going to click Browse S3, and it's going to present the buckets I have access to. And I already uploaded the help pages here in this bucket. So I'm just going to select this one and click Choose. The next step is to select the IAM role I want to use for this particular data source, and I've already created one. The last step is to actually set the sync schedule. This is the frequency at which I want the connector to run and keep the repository in sync with the index. Let's keep it at run on demand so I can actually trigger the sync process manually. I'm going to click on Next. And this is the final review and create page. It's just a summary of my settings before I create the data source. All looks good. I just click Create. And there my data source has been created and active. So when I go back to my data sources, I can see that my S3 pages is created, it's active, and it's suggesting here at the top that the next step is really to sync that data source because there's no content in there yet. So when I click on Sync Now, the data source is now syncing and bringing the data in to make it searchable. Once the sync is complete, this status here will change to notify me. So the sync succeeded, and if I want to see the summary, I just click on the data source itself to look at the run sync history. And here it tells me the last run succeeded, the start time, the end time, how many documents were added, how many were deleted, failed, and modified. And since this was the first time I indexed those documents, the only number I'm going to get here is the total number of added documents. Great, so now this content is searchable. Let's add the second data source. Go back to my data sources. Let's add a data source, and we're going to look at Salesforce now. To keep this configuration demo short, I'm just going to show you how to configure the Salesforce connector, but we're not going to index the data. I put all of the help pages in the S3 bucket so that we can jump to the search quickly. So we click on Add a Connector. I'm going to give my Salesforce data source a name. I'm going to call that SF for Salesforce. And then I'm going to skip the description again. Click Next. Here's where you're going to put your Salesforce domain. So let's give it just kendra.salesforce.com. You'll assign an IAM role also for this data source. So let's just give it another role that I've created in the past. Click Next. Here you're going to choose the credentials you want to use to connect to Salesforce. And I've created one in the past, so I'm just going to reuse that one. As I move down the page, I can start choosing now the objects from Salesforce that I want to index. For example, if I want to crawl the attachments, I can select the attachments. And Salesforce has a series of objects that it stores. It has accounts, contracts, leads, documents, opportunities. So you can choose either all of them to index all of them and make them searchable, or just selectively pick them. So let's say I just select account here to make the account searchable. I also have a choice of selecting knowledge articles if I want to index those, chatter feeds. And the last step here is to set the sync run schedule, similarly to the S3 connector. So how often I want the connector to run. Let's just set it to run on demand since we're not going to index any content. I click on Next. So Salesforce in general is a powerful application that's highly customizable by its users. And Kendra's Salesforce connector therefore provides a simple and yet flexible setup to capture our customers' individual needs in Salesforce. So in this particular step, which is optional, Kendra comes pre-configured to keep things simple for the user and provides a default mapping of fields from Salesforce to the Kendra index. So unless you want to customize how you want to bring those fields from Salesforce into Kendra, you don't have to worry about this. Just use the default settings and your data will be ingested. So I'm just going to keep the default settings here and just click Next. This is the last page where I review and create the data source. Just summarizing my settings. All looks good. The schedule is on demand. And I've done no customizations on the fields, so I can just click on Create. And that's how you add data to your index to make it searchable. So let's go to the Search Console now. So let's try our first Kendra searches against these help pages we've indexed here. Let's say I've bought a Kindle book and I just want to return it. So I may want to just type return Kindle book. And I get a response under Kendra's suggested answer that tells me how to return the book. So to return a legible Kindle book, it tells me the process of how to do this. Okay, that's pretty relevant. I get my answer. I can always go to the web page to find out more about that particular process. But let's say I actually bought a hardcover book and I want to return that. And I'm wondering, well, how much will Amazon refund for postage? So I can ask a very simple question. How much Amazon refund postage? And I immediately see my answer here, up to $20, which was extracted from this passage here from a document in the help pages. Now, if we want to compare the experience by doing the same thing on the website, let's copy the question here, go to the website, and this is amazon.com/help. It just takes you to this page, and you can actually type in here the same question. So I get a list of documents back, and they seem relevant. They talk about returns and refunds. So when I click on this, okay, I see a table of contents. I don't see my answer yet, which is the amount I'm looking for. And if I scan through these, I need to click into these documents to figure out where that particular amount may be located. And after clicking through some of these documents, I realized that the answer was actually in the About or Return Policies. And still, I'm in this document and I still have to read it and scan it to find an amount. And finally, I find it here. Amazon will automatically refund up to $20, which is the exact same answer we saw earlier with Kendra. The difference is that Kendra brought it up immediately after I clicked on that search button. Let's take another example here. I recently got a rebate offer from Amazon, and I'm wondering, how long does it take to actually process that rebate? We can ask the question, how long to process rebate? And it gives me an exact answer of 12 to 15 weeks. And again, it was extracted from one of those documents in the help pages. I don't have to go through any documents. My answer is here. I'm done. I can go back to what I was doing. Let's say I use the Amazon Prime Rewards card, and I'm wondering about how to redeem my reward points. So I could type in the question right here, redeem reward points. And this is a simple keyword query. So let's see how that goes. So Kendra's suggested answer at the top here is bringing back a passage that explains to me how this works. Points will be removed as a payment method from your order. The reward points to redeem will be deducted from your rewards point balance when your order is placed. Great. So now I know how that works. Well, what if I cancel an order that I placed with my points? And I want to find out, for example, how long does it take to get those rewards point back? So I can type in how long to refund points. And again, it tells me here, within 24 hours. Last question about these points is, I wonder if my points will expire one day. So I can ask the question, do my rewards points expire? And in the answer here, I can see the bolded section that says, points do not expire as long as you are a card holder. That's a pretty clear answer. The passage extracted is spot on. Let's take a final example here where I just bought a product on Amazon and I'm trying to install it or configure it at home and I'm having issues with it. So I need to contact the home repair service and I'm looking for their phone number. So I can type in phone number for home repair service. And Kendra is able to recognize these numbers in the documents and pull them back into your search results. So this wraps up the first demo where we saw Kendra's ability to answer a very wide range of questions, demonstrating its ability to handle customer service and self-serve applications really well. Let's look at another demo. This search application is the result of a recent collaboration with the Allen Institute around accelerating research for the scientific community around COVID-19 research data. This showcases Kendra's ability to find accurate answers in a highly technical domain. So if I come to this web page and I want to start exploring this data set, I may want to start with a question like, where did COVID-19 originate from? To see if it finds a location. And sure enough, here Kendra brings me back the recommended answer with the location highlighted in black. That's pretty spot on. How about trying a time frame question? When did COVID-19 start? And it gives me back December 19th, the exact time frame that was published in these papers. Now, after asking these two general questions, I may want to explore the data in more depth, so I may want to ask a more technical question. Let's ask, what's the incubation time for COVID-19? And I get 5 to 6 days, the exact duration extracted from this passage. Okay, great. Let's try another example. So now I'm wondering, how long does the virus survive on different surfaces? So I may ask, how long does COVID-19 live on plastic? And again, it extracted a very specific answer from highly technical documentation without training Kendra on this specific data set. Since Kendra performed semantic search, you can actually ask the same question in a different way or slightly shorter. Let's see what happens when you do that. So how long? COVID-19 on plastic. And we get the same answer, of course. Let's take an example of a definition. We heard during the pandemic about fever clinics, and I want to know more about what those are. So I type in the question, what are fever clinics? I actually have a typo in my question here, but Kendra was still able to find the right answer. It's actually bolding here. The fever clinics are outpatient departments for the assessment and treatment of febrile patients. Great. And talking about fever, I'm wondering, how warm do I need to get in order for it to be considered a fever? So I'm just going to type in the question here. What's the temperature for a fever? And again, at the top, I can see the bolded answer here that the American College of Critical Care Medicine and the Infectious Disease Society of America suggested a core temperature of 38.3 degrees Celsius or higher should be considered a fever. Again, I got my answer right there in search results, and I'm done with my search. No need to go digging in documents looking for precise answers. So this wraps up my second demo, demonstrating Kendra's ability to return highly accurate answers from highly technical content. Let's go back to our presentation. Now we're going to talk about how our customers are using Kendra. RegRanger is PricewaterhouseCoopers' service offering for regulatory compliance. Their goal is to help their customers get to the answers they need faster, even when the answers may be buried in documents over 100 pages long, so they can understand regulatory information faster and make decisions more quickly and confidently. As an early Kendra adopter, PwC is now developing and testing enhanced search capabilities for their next version of RegRanger that will allow users to ask natural language questions, which is a dramatic improvement over traditional keyword searching methods and manual reviews of documents. At 3M, it's all about accelerating material science research. With over 8,000 material scientists and 1,200 new projects every year, 3M needs access to information from prior relevant research, information that's buried in the many patents they hold in their huge knowledge base. Kendra lets their scientists find the information they need by handling natural language queries quickly and accurately, allowing them to innovate faster, collaborate more effectively, and accelerate the ongoing stream of unique products for their customers. Baker Tilly is a large consulting services company offering accounting and financial advisory. They work closely with their customers to provide insights on market conditions, customer preference, and trends. With Kendra, they reported that their clients were able to surface relevant information 10 times faster than with SharePoint search. For example, Amazon Kendra allows product managers to ask questions in everyday language such as, "What parts are made of titanium?" and quickly surface an answer or a list of relevant product manuals, technical bulletins, service alerts, and patent registrations, something that was previously not possible with keyword search solutions. WorkGrid is a wholly owned subsidiary of Liberty Mutual. They developed a platform to quickly implement chatbot applications that allow employees to get quick answers to frequent queries and automate tasks using a friendly natural language interface. One key part of any enterprise chatbot is the ability to answer the myriad of questions that come from employees. But that can get challenging very quickly when chatbots are trained on predefined intents. Amazon Kendra makes it possible to extract answers directly from unstructured data across multiple repositories. So we're very excited to see WorkGrid exploring Kendra's natural language capabilities to enhance their chatbot platform. Let's talk about what we just launched recently. We introduced a new edition of Kendra, the Kendra Developer Edition. We also launched 3 new cloud connectors for OneDrive, Salesforce, and ServiceNow. Enterprise Edition customers can scale out their applications using query and document capacity units. We introduced expertise in 8 new domains for Kendra, and we improved accuracy and performance overall for the service. The Kendra Developer Edition provides developers with a lower cost option to build proof of concepts and experiment more with Kendra. It provides the same features as the Kendra Enterprise Edition, supports 4,000 queries a day, 10,000 searchable documents across 5 data sources. It runs on one availability zone, so it's ideal for development purposes, not recommended for production workloads. and the Kendra Developer Edition provides a free tier. We introduced 3 new cloud connectors. At preview last year, we had Amazon S3, SharePoint Online, and databases, and the new ones introduced at GA are for OneDrive, Salesforce, and ServiceNow. Kendra Enterprise Edition customers can now scale out their search applications by increasing the capacity on the number of documents they need to search over using our new document capacity units, which add increments of 500,000 searchable documents on top of your existing capacity. Similarly, Enterprise Edition customers who need to increase their daily query capacity can increase this by adding query capacity units. Each query capacity unit increases the capacity by up to 40,000 queries per day. As mentioned earlier, we introduced 8 new domains for health, HR, legal, telecom, media entertainment, travel and leisure, automotive, and news. These are in addition to the ones we launched at preview, which were IT, finance, pharma, insurance, energy, and chemicals. This means that Kendra can find very precise and very accurate answers in all of these domains out of the box. On the pricing side, the Kendra Enterprise Edition starts at $7 an hour and provides support for 500,000 documents and 40,000 queries a day. To scale out from there, Kendra Enterprise Edition customers can increase their capacity by adding document capacity units or query capacity units at $3.50 each per hour. The Kendra Developer Edition starts at $2.50 per hour and supports up to 10,000 documents and 4,000 queries per day. The connectors are built on a pay-as-you-go basis. If you're just using Kendra and pushing content into the index using the APIs, you're probably not using the connectors, therefore you will not be billed for connector usage. On the other hand, if you need our connectors, either Salesforce, ServiceNow, S3, or any of the other connectors we offer, we bill on a per document scanned and on the time the connectors are running to bring the content from your repositories into Kendra. You can get started today with Kendra. Just go to aws.amazon.com/Kendra. And this wraps up our presentation for today. We hope this was informative. We thank you for your participation and hope to see you soon in a future webinar.